Okay, so we'll get started with chapter 5 when we're talking about measurement concepts. And just to start out, we're going to talk about reliability. We just talked about validity and whether something accurately measures what we are purporting to measure. And so now we'll talk about reliability. This is the consistency or stability of a measure. And whether we can garner the same outcome over and over. So, is it reliable? We talked about the example of the thermometer in the prior chapter, and it would be valid. A thermometer is valid if it is accurately measuring the temperature outside. Now, when it comes to reliability, on the other hand, this is going to be based on, can we get the same measurement or temperature over and over and over again? And this does not have to require validity because a thermometer could technically not be calibrated, and thus you will get an inaccurate measure, but you may get that inaccurate measure over and over. That would indicate that that thermometer does have high reliability, but it has low validity. So again, reliability is the consistency of a measure over and over again. All right, so we also have the true score. This is the real or true value of a given variable. We also have measurement area error. This is the degree to which a measurement deviates from its true score. And then we have the Pearson product moment correlation coefficient. Okay, so we're talking about basically the Pearson correlation coefficient. This is going to be run in order to determine the reliability of a measure. And you are not going to need to do this necessarily with the survey that you develop, but it is something that you could run statistically through like a pilot study to determine how reliable is your survey over time. So this Pearson coefficient it's a common method of calculating a correlation coefficient used with ratio and interval scale data. So if your survey is a Likert scale, so somebody determines whether or not they agree with a statement from 0 to 10, you would be able to run this statistical analysis. And this Pearson, and you will, as you go through literature, you will see these Pearson correlation coefficients, and this is symbolized by R. And it can range from 0 to 1 and 0 to -1. And the closer to 1 or -1, the stronger the correlation with between variables. So here we go. So with comparing data of a reliable and unreliable measure, a reliable measure, again, is going to be, you're going to get consistent results over time, whereas an unreliable, you're not necessarily getting those consistent results. All right, a couple of different types of reliability, test retest reliability, kind of what I'm talking about here. It's assessed by measuring the same individuals at 2 points in time and comparing the results. So this would be like you give a survey to somebody now, you let time go by, and you survey them again, and you're looking at how closely their scores correlate, how reliable or how consistent are their scores over time. And a high correlation between the test and retest indicates that, in fact, your survey is reliable. Alternative forms of reality. It uses two forms of the same test given to the same individuals at 2 points of time. This avoids problems with participants remembering and repeating earlier results as well. So there's also internal consistency reliability. It's the assessment of reliability using responses at only 1 point in time. This could be done through a pilot study. And because all items measure the same variable, they should yield similar or consistent results. Again, if you were to conduct a pilot study of the survey that you are conducting and you sampled 10 individuals, what you're looking for amongst individuals are pretty consistent scores because, again, you are measuring the same variable in your survey, and so they should be pretty consistent. You should not see differing answers to similar questions. They should be pretty consistently responded to. And so if there are big differences in how people are responding to similar questions, that's not a very reliable survey. So one indicator of internal consistency is going to be split half reliability. This is going to be the correlation of the total score on one half of the test with the total score on the second half. So a high correlation is going to indicate the questions on the test we're measuring the same thing. We are measuring one variable, and the way in which we do this is through Cronbach's alpha. And it's not on here, but the sign that you would see in the literature is a little alpha sign. And this is the average of all possible split half reliability coefficients. There's also item total correlations. These are the correlations of each item score with the total score based on all the items. So what you're looking for are high levels of correlation among items and responses. Low correlation items are actually measuring a different variable and can be eliminated. So if you were to conduct a pilot study of your survey and you find that, oh, this specific item has a very low correlation with the overall survey items, you would be able to either eliminate that item from your survey because it's measuring something else, or you alter it to possibly better measure the variable that you want it to. Also, we have inter-rater reliability. This is the extent to which raters agree in their observations. High correlation indicates that raters agree in their ratings, and this is the commonly used indicator is going to be Cohen's kappa. We don't really use that as much. What you're going to see more often than not is a Cronbach's alpha. The reliability does tell us about measurement error, but it does not tell us whether we have a good measure of the variable of interest. Like, are we actually measuring what we purport to measure? Kind of like we were talking about with that thermometer. Okay, just because we get similar readings on that thermometer over and over and over, indicating reliability, if that thermometer is not calibrated correctly, we may not accurately be measuring what the temperature is outside. So we might have a reliable measure, but we do not have a valid one. Okay, so here's your 3 strategies for assessing reliability. Then we can talk about, again, we can go back into validity. And I know we're kind of beating this to death, but again, going over this and over this is helpful in kind of delineating the difference between validity and reliability. And so, again, if we're talking about whether something actually measures what it purports to measure, we're talking about construct validity. Is the thermometer actually accurately measuring the temperature outside? If so, it has high construct validity. We also have face validity. This is the content of the measure appears to reflect the construct being measured. So we can look at a thermometer and say, well, it kind of looks like it's measuring. It's kind of measuring the temperature outside. And if it's, say it's 70 degrees out and it says 0 degrees on the thermometer, at its face, you might say, well, okay, this is not really accurate. But if it's fairly close, you might say, okay, it must be accurately measuring the temperature. Then we have content validity, and this is the content of the measure is linked to the universe of content that defines the construct. So again, are we measuring what we purport to be measuring in regard to the specific construct or variable, whether that's temperature, whether that's depression, whether that's anxiety? Are we actually measuring what the construct is? Then we have predictive validity, and this is when scores on the measure accurately predict behavior on a criterion measure at a future time. So are we accurately measuring something that predicts behavior in the future? So, for example, in a study in which you are trying to determine, like, do just world beliefs predict conspiracy beliefs as well? And so what we're looking for is that, like, okay, just world beliefs do highly correlate with conspiratorial beliefs. So what you would expect predictively is that in the future, those with higher just world beliefs do in fact have higher levels of conspiratorial beliefs. So we're actually predicting future behavior. We also have concurrent validity. And this is when scores on the measure are related to the variable that's measured at the same time. Convergent validity, scores on the measure are related to other measures of the same or similar constructs. So let's say you develop a survey that measures depression. Okay, so what you might do is look at the convergent validity of that in comparison to like the Beck's depression inventory. Then you might look at discriminant validity, and this is scores on the measure are not related to other measures that are theoretically different. So in this case, you might look at, your depression survey that you developed. And again, maybe it's based on the DSM-5 TR criteria of depression. And then what you do is you look at, okay, how different this is. And of course, you would run this study with a sample of participants. You compare and contrast it to possibly a different survey that conceptualizes or defines depression in a different way. And what you're looking for is differences. You're looking for higher differences because you conceptualize depression differently than this. So you want there to be big differences in discriminant validity. So these are all going to be based on the construct that we are measuring or the variables. Yeah, it's important to it's incredibly important to behavioral research, as is like reliability is going to be incredibly important. Validity is going to vary depending upon whether you're doing an experiment or non-experimental research. But again, you have to have a reliable measure. You absolutely have to have a reliable measure. And here's some more examples of each type of validity. And then we have reactivity. Okay, so this is a potential problem when you measure behavior. And so it's a measure or assessment or a survey. It's said to be reactive if the awareness of being measured changes an individual's behavior. So if somebody knows, for example, they are being surveyed based upon their depressive related symptoms, that might actually change how they answer the questions. And measures of behavior vary in terms of their potential reactivity as to, okay, how is this going to change an individual's behavior as to how they answer the questions? Now, there are 4 different kinds of measurement scales, and you can use any of these in your own survey. But you have nominal scales. So we have nominal, ordinal, interval, and ratio. And this also has to do with types of data. But nominal scales, they don't have any numerical value or quantitative properties. The categories or groups, simply differ from one another. Okay, then we have ordinal scales. This allows us to order the levels of the variables under study. Okay, these two are going to be, they're not going to be quantitative. They are going to be basically words in nature. Then you have numerical scales. I would recommend using interval scales. And your most common interval scale is going to be a Likert scale. And these are going to be numeric scales in which intervals between numbers on the scale are equal in size. So you might have a Likert scale in which somebody can rank their agreement with a statement from 0 to 10. Or from and you can attach words to it like strongly disagree, disagree, neutral, agree, strongly agree. That would be an interval Likert scale. Even though you have words attached to it, there are underlying numbers as well. And just a couple of examples here. Nominal scales, this would be like gender. If you were to use just 2 genders, male, female, you may also include more genders as well. Ordinal scales, this would be like education levels. So does somebody have less than a high school education, college degree, graduate degree? And again, there's different levels of it instead of one or the other up here. Ratio scales, they're going to have an absolute 0 point that indicates the absence of the variable being measured. And we are not going to use this in this course, but there would actually be a 0. There is the absence of that variable at all. And the conclusions drawn about the meaning of a particular score on a variable depend on the type of scale used. So interval and rating scales provide quantitative information about variables. Okay, that's kind of what we're talking about here with your Likert type scales. Nominal scales, they don't. So your nominal scales are only going to indicate like labels. The scales used in a study determine the types of statistics also that are appropriate for analyzing its results. So here's some examples as well. In regard to nominal, they're categories: left-handed, right-handed, eye color, college major. And there's nothing quantitative about this. You can't attach any sort of numerical value to any of these. Ordinal, again, there's a rank ordering, but the numeric values are limited. Yeah, 2, 3, 4 restaurants, TV programs by popularity, college education, um, and the intervals between items. You don't know. Like, what's the gap between any of these? Interval, yes, you have numeric properties that are literal, and we assume that there's an equal interval between the values, measure of intelligence, aptitude test, temperature, and there's no true zero. The ratio, again, 0 indicates absence of variable measured. So like reaction time, age, frequencies of behaviors. And we can form ratios. One person weighs twice as much as another person. So even with reaction time, you might say like, okay, a 0 would literally be not reacting. Or you could say like, in how many seconds somebody's reacting to something. But the 0 would actually indicate a lack of that behavior in its entirety. So hopefully that just gives you kind of a basic idea of these concepts. Again, if you have questions about reliability, validity, the scales, Likert scales, whatever it is, please let me know. I'm here to help you, and I hope you have a great day.